Hello everyone and welcome to this video. Okay, let us start our discussion. Today we want to talk about the theoretical yield and the experimental yield. Okay, this experimental yield is basically the yield which you get after performing the experiment. Okay, and this theoretical yield, it's basically coming from the word theory. It is something that you expected and you performed your calculations on paper and you calculated it that this much you should get, and this much is basically you actually get. This is your expectation, and this is, you can say that this is the reality. And we know that expectations are always higher than reality. Same goes in chemistry also. This theoretical yield is like always more than this experimental yield. This is always more and this is always less. What is the reason? What is the reason that this is always less, this experimental yield? First reason, it is possible that some of the product is lost. Like from a reaction vessel, some gas is lost or something happened, some mistake happened, and some reactant is lost from the reaction vessel. In paper, this is not the case. In theory, you will write it the amount and it will be the same. But in experimental conditions, it is possible that the some of the product is lost. Second reason, impure reactant. On paper, when you are doing the calculation, you take 100% pure uh, reactants. But in reality, it is possible that the reactant you bought is not pure. It has some impurity which will affect the yield. Yield is basically the output, how much output you can say, how much product you are going to get, and it will affect the process. Third reason, like there is some change in reaction conditions, like the pressure has changed or volume has changed, or any sort of temperature is changed, like reaction conditions change. Sorry about volume. Like temperature, like pressure. What can be the other reason? Another reason is like there is a reverse reaction going on. Equilibrium conditions are disturbed, so there is a reverse reaction. It will affect the yield. On paper, these things do not matter. One more effect, there is some side reaction going on. Like the reactant you bought has an impurity in it. Because of that impurity, another reaction goes on in the reaction vessel, which will also affect the amount of product. So these are some factors which shows that why the experimental yield is less than the theoretical yield. Now let us see a question, an example of how we can calculate the yield. We have this example, like respirators are being used. We have given the equation I2O5 plus 5CO will give us I2 plus 5CO2, and we are given the quantities. We have 100 gram of I2O5, 33.6 gram of CO, and we want to calculate the theoretical yield of carbon dioxide. If you are interested in this product, experimental yield is given to us because we are not going to perform experiment on a paper, so it is given to us, and what we want to calculate is the percentage yield. How we can calculate the percentage yield? The percentage yield formula is experimental yield over theoretical yield times 100. This is the formula. Now in this formula, we are given the experimental yield, but we want to find the theoretical yield. Now let us find the theoretical yield here. As we know that to find the theoretical yield, first thing we need is the limiting reactant. We want to see out of these two reactants, which one is the limiting reagent or reactant. So after knowing that, we will know how much product we will get. So let us find the limiting reactant first. We have another video on limiting reactant. If you have any problems on limiting reactant, you can check that. Okay, we have two. We have I2O5 and we have CO. Two reactants. The quantities are given to us. I2O5 is 100 gram. We have 100 gram of I2O5 and we have 33.6 gram of carbon monoxide. So let us convert it into moles. We need the value in moles. So we have 100. We need the masses of I and O. We have it from the product table. This is around 126.90 plus 5 into 16. And for carbon monoxide, how can we do it? 33.6 divided by 12.01 plus 16. So this one will be how much? This is around 0.2996 mole and this will be around 1.20 mole. It is not true that the thing which is present in lesser amount is your limiting reactant. We need to check it. And to check it, we need the equation. We have the equation which is I2O5 plus 5CO. It will give us what? I2 plus 5CO2. Okay. This is not important for us. This is important because we are told in the question that we want to calculate the yield of carbon dioxide. Okay. Now we need to find the limiting reactant. So we have here, according to the equation, you see 1 mole of I2O5 is reacting with 5 moles of CO. This we can see from the equation. 1 is reacting with 5 moles of CO. How I know it? From the equation. Your equation should be balanced. Like 1 mole is reacting with 5 moles of CO. But the point is you don't have 1 mole, you have 0.2996 moles. You have 0.2996 moles. So how much you need, you don't know, you can calculate it by putting an X. Do the cross multiplication. What we get here? 5 into 0.2996. It will be around how much? 1.5 moles. So you need 1.5 moles of CO. But you have how much? You have only 1.20 moles. It means this is short. We have less. This is less. So when certain amount of I2O5 is consumed, CO will be finished. So when the one which is finished, consumed earlier, is your limiting reactant. So in this example, our limiting reactant is what? Our limiting reactant is carbon monoxide. So this carbon monoxide is the one which will control the product. It will control the amount of product formed. So let us see now the product case. We need again the equation. Let us rewrite the equation here. We have the equation in the form of I2O5 plus 5CO. It is giving us I2 plus 5CO2. Now we know that this is our limiting reactant. This is the one which will control the amount of product, and this is our desired product which is given to us in the question. So let's see. We have CO and we have CO2. We can see that 5 moles of CO is giving us 5 moles of CO2. 5 moles of CO is giving us 5 moles of CO2. So how much CO we have in our stock? We have 1.20 moles. This one. We have 1.20. So 1.20 will give you how much? It gives you X. So this will be how much? Same, 1.20 moles. So you should get 1.20 moles. This is simple. You can do the cross multiplication. So 5x equals to 5 into 1.20. This 5 will cancel this 5. You get 1.20. So according to calculations, I should get 1.20, but I am getting how much? 0.9. And why it is less? We have discussed the factors. These are the possible factors, which is the reason that experimental yield is always less than the theoretical yield. Now we want to find the percentage yield. How we can do it? It's on you. You can use the moles also. You can use the grams also. So it will be like 0.9 over 1.20 times 100%. So we get around 75% yield. It means we have a loss of 25%. This is how we can calculate the yield. This is a very important question in stoichiometry. Thank you so much for your time. I hope you understand it.